Okay, today we're going to look at graphing quadratics and identifying the key features of graphs as well. So we're going to start off with a little bit of review here, right? So we're going to identify domain and range. Remember, domain refers to your x values, so left to right, and range refers to your y values, so up and down. So as we look at a graph, the first thing I usually look at, let's look at domain. So you're asking yourself how far to the left and how far to the right does this graph go? In general, I kind of think about this left side and think, oh, it goes down and to the left, down and to the left, down and to the left. But with domain, we only care that it goes to the left. And then it goes down and to the right, down and to the right, down and to the right. On the other side, we only care that it goes to the right with domain. So domain here, if it goes all the way to the left, that's negative infinity. All the way to the right is positive infinity. As we talk about range, now we're looking at how low and how high. Since the graph goes all the way down, right, it's got these little arrows here, that's negative infinity. But the highest point it has is right up here at 4. So we're just looking at that y value, so it is 4. You're not using the x value of negative 3 because of range as your y's. And in this case, we use a bracket because it actually touches that point. Okay, let's look at the next one. Remember, this is an exponential graph. So your domain, not that that matters, but it's just good for kind of remembering. Your domain will go all the way, let's see how far left. It keeps going to the left and left and left. So it goes to negative infinity. And then it goes up and to the right, up and to the right, up and to the right. So it goes to positive infinity. Your range is then going to be how low to how high. So the lowest it goes here is it kind of levels off here at negative 2. So that's a y value of negative 2. And then it keeps going up and up and up to infinity. Your infinities always have a parenthesis, but here, since it never actually touches that negative 2, this will also get a parenthesis for range. Okay, one last one. Domain in this case, the furthest left it goes is here at negative 4. Since it's an open circle, we get a parenthesis. And then on the right side, you've got an arrow, so that goes to infinity. Your range, the lowest value is here, right here, these ones, which is our 1. So the range starts at 1, and it touches there, so it's a bracket. And then this arrow over here is going to be the highest it goes, so it goes to infinity. Okay, x and y intercepts. So x-intercept and y-intercept is where it touches the x and y axis. So here your x-intercept is at negative 2, that's right as a point, so that's negative 2, 0. Your y-intercept's at 3, so it's 0, 3. Okay, in this case, we've got 2 x-intercepts. So we've got negative 6, 0, and 2, 0. And then your y-intercept, where it crosses the y-axis, which is at negative 4, so 0, negative 4. Okay, this next one, x-intercept, negative 4 and 1 are obvious, but then people kind of question about 4 in class. In this case, remember, it just has to touch the axis, so that is an x-intercept, even if it doesn't cross through there. So you'd have negative 4, 0, 1, 0, and 4, 0. But your y-intercept usually is only ever 1 point. So in that case, it's at 2, so 0, 2. Okay, let's next look at what it means to be increasing versus decreasing. So increasing, remember, is going up. Decreasing, people think about it as going down. The thing to remember about our intervals is we're going to use x values. And the only other thing that I'd say here about going up and down is you have to read the graph from left to right. Okay, so I always like to start off and just be like, okay, let's just look at the graph. This first part of the graph as we go left to right is going down, so it is decreasing. Why not? Let's go ahead and write that interval for a minute. So decreasing in this case, all the way from the left, which is negative infinity for x values, and it stops here at this x value right now, which is at 0. With increasing and decreasing, I always use parentheses. Don't worry about if it's touching or not, because I always think about that point where it crosses as like a turning point. Okay, so now let's look at the next part. So increasing. This part is the part going up, and it's increasing. So in this case, the increasing interval starts at that same x value of 0, but goes all the way to the right, which is infinity. Okay, I do the same thing with like my other graph. So, hey, let's take a look. As we start, we're going down, so it's decreasing. It's got an arrow on that side though. The flat part we actually call constant, so it's neither increasing or decreasing, but then this part is increasing. So as we look at writing those two intervals, for decreasing, we've got, it has the arrow that goes all the way to the left, so it goes from negative infinity to negative 3. And then for increasing, it goes from negative 1 is that x value, right, to 2. Okay, one last one. This one starts again as decreasing. It goes down. And then you'll notice it goes up for a little bit, but then it goes down again here. So you'll notice this one has 2 decreasing intervals and 1 increasing interval. So let's start with the decreasing. It starts decreasing all the way on the left. So that's negative infinity to negative 1. And then it also decreases from 1 to infinity. To join those two intervals, we put a little u between them. Whereas for increasing, it starts at negative 1 as an x value and stops at 1. Okay, let's go ahead. The second part of our lesson today is graphing quadratics. So for graphing quadratics, I would use your graphing calculator. So remember, we're going to go ahead and hit y equals, and then we're going to put in, we have 2x squared, that was not x, try again, 2x squared minus 8x plus 4. You're welcome to go ahead and just look at graph, and it will show you that 10 by 10, but I don't feel like this is super accurate. So if you hit second graph, then it gives you this table of values, and know you can scroll up or down to kind of see things. So once you got those table of values, you're just plotting points. So I would maybe start with this first point at 0, 4. And then go to the next one. You got 1, negative 2. And then I've got 2, negative 4. And then I have 3, negative 2. And I've got 4, 4. That's enough for us to see what's happening here with our graph. And what I like about this too is you can easily identify that, hey, this 2, negative 4 is the vertex. The other way to kind of look at it in the table of values is you see how like it kind of mirrors things, the y values on both sides. You see how there's a negative 2 on both sides and there's a 4 on both sides. It's centered around this one point, which is the vertex. Okay, so if you do it again, this time be a little careful because there's a negative, and you do need to use this negative rather than the minus sign, otherwise it'll tell you have an error. So once again, I never think it hurts to look at the graph because I think sometimes people forget, oh, hey, this opens down, right, because there's a negative out front. But I really like looking at second graph and seeing this table of values. In this case, if you kind of go over, you may see, hey, it looks like it mirrors here around this point of 3, 4. So in this case, 3, 4 is my vertex. But then 4, 3, or 2, 3 is next. I have 1, 0, and I've got 5, 0. I even have 0, negative 5, and 6, negative 5. Okay, those are all the points I can fit on my graph. Go ahead and connect them, and we've got a quadratic. So as you take a look at these, what part of the graph matches something from the original equation? Remember this plus 4 or this minus 5 represent that y-intercept. Okay, let's look at this next one. This next one we call intercept form. You can also think about it as factored form. It should be kind of familiar to last time. So you've got x plus 4, and then x minus 2. And then we can hit graph if you want to just kind of double check what it looks like. But I really like the second graph to kind of see what things are. And here it looks like we may want to kind of scroll up some more, which makes sense because the graph was kind of on the left side of the grid. And we got some points we can plot. So feel free to do as many of these as you want, like -5, 7. I've got -4, 0. -3, -5. -2, -8. -1, -9. And then we have like the mirror image on this other side because the vertex was at that -1, -9. So we got a graph that looks something like this. Okay, do it one more time with this next equation. We got negative x minus 6 times x minus 2. And I'm just going to skip to the graph here, this table of values. So those look too big, so I'm going to scroll down a little bit. These ones look more reasonable. It looks like it's kind of centered here around this 4. So 4 is my vertex. 3 is a point I want to plot, as well as 5 I've got 6 and 2 and then 1 -5. So that's 7 -5. Okay. As you take a look here at these ones, so remember this is called intercept form, and I want us to think back to like what we did yesterday. So if I set this equal to 0, 0 equals x plus 4, x plus 2, this really means that x equals a -4 and x equals a -2. Remember how it comes opposite? I must have typed that one in wrong. We're going to have to go back and check that one in a second. Okay. Let's type it in. I think I typed it in wrong. And you guys weren't here to correct me. So it's like x plus 4. I think I did x minus 2 and I should have done x plus 2. I totally apologize about that. Yep, that makes it a little bit different. Okay, let's go back real quick. So let's just redraw this real quick before we talk about what I was just about to talk about. So -3, -1, -4, -2, 0, and then I have -1, 3, and then 8. So 3 and then 8. Okay. So now notice, okay, let's go back. So when we set those equal, we get -4 and -2. And notice, those are your x-intercepts. So same thing here. When you solve this, you get x equals a +6 and a +2. And notice those are your x-intercepts. So this factored form really helps you with your x-intercepts. Or if I ask you to solve a quadratic and you're really struggling, why not graph it and just check where it crosses the x-axis? Okay, this last one we call vertex form. And we're calling it vertex form because, hey, it's talking about the vertex of the equation. That's going to be the easy point to identify. Let's go ahead. If we take a look at the graph, I can then look at second graph. It opens down because there's a negative out front. My vertex here is at this 1, -3. And then I also have 0, -4. And then I have 3, -7. I can kind of mimic that on the other side if I want as well. So the graph just looks something like this. So let's just look at it. So the vertex here, we got 1, -3. Remember this -3 means down 3. And then it's the opposite of what's in the parentheses, so we go right 1 rather than left 1. So it makes sense. My vertex is 1, -3. I could use that same idea over here and be like, okay, this goes left 3, opposite of what's in parentheses, and then down 1. So left 3, down 1. I'd expect my vertex to be at -3, -1, but let's just double check. So x plus 3 squared minus 1. So let's just look at graph. Hey, that is what it looks like, but if I look at second graph, negative 3, negative 1's on there, but I also have like 4, 0, 2, 0. I've got negative 1, 3, and I have 0, 8. So there we go, we got our quadratic. And once again, it notches, like we said, the vertex. All right, so with graphing, I definitely would use the resources given to you. You're welcome to use your graphing calculator, or Desmos is also another option. But your school Chromebook should have the same graphing calculator that I was just using. Good luck with your assignment.